So this is where living in the Midwest, we're sort of at a disadvantage, but if you live near a large body of water, like the oceans, you will have on the beaches, you'll have tides, actually in the middle of the, where the oceans meet the land and on the beaches. So every 12 hours, I'll try to explain why this is, but every 12 hours the ocean will ebb up onto the beach, and then it will flow back out. Okay, at 12 hours you'll have another high tide. Okay, 12 hours you'll have another high tide. And this is all has to do with the large bodies of water actually being kind of lifted up off of the earth, okay, due to the presence of the moon. So kind of orient yourself. I'll kind of put a dot here. I'll put North Pole here, and you guys know that the Earth spins on its axis of rotation, and the North Pole is 90 degrees latitude. And it's all about, we've been talking about counterclockwise, so we'll go ahead and put a counterclockwise spin. So basically, as the Earth spins or rotates, this kind of high blob, and notice that there's an elongation of the oceans towards the moon, and there's also an elongation of the oceans directly opposite where the moon is. So we have high tides over here, and we also have high tides. Where did my thing go? There it is. We also have high tides. Goodness, over here. Okay. Okay, so those high tides are kind of constant, and the Earth kind of rotates underneath it. So you figure at 12 hours the Earth will be here, okay, and at 12 more hours the Earth will be here. Okay, of course, though, the moon is also in motion, okay, so it's not exactly 12 hours. And actually, this bulge of water that's our high tides, it's not exactly lined up to the location of the moon either. It's off by about, I think, 10 degrees, and that has its consequences as well. Okay, high tides. So there you go. What causes the tides? And the reason there is this pull is due to the force of gravity that we've talked about earlier in the course. So we have some specially high tides and some specially low tides depending upon where the sun's at in all this mix. So if we kind of look at three objects, okay, and we have the first scenario up here. The three objects are the Earth experiencing the tides. You can kind of see the pull, kind of the bulges of water there and there, and the moon, okay, and where the sun is. So if the sun is kind of lined up in line with the moon, okay, it like gives an extra oomph to that gravitational pull. So that the alignment between those three objects happened twice with regard to lunar configurations. At full moon, we've got the Earth, moon, and the sun, and also at new moon, okay? So at new moon, we have the sun, moon, and then the Earth. So these are actually what we call spring tides, and they would happen twice a month, right, every 2 weeks, because the full moon and the new moon are separated by about 2 weeks. Then in contrast to that, we have something called Neap Tides. Neap, I like that word, Neap. Neap tides, again, have to do with the relative position of these three bodies, but in this case, the sun is kind of acting against the pull of gravity of the moon. So we see here, we see here still kind of the bulges here, high tides in the vicinity of the moon, and I've shown the moon in two positions as the moon orbits the Earth. Down here we have first quarter, okay, and then 2 weeks later, as the moon orbits the Earth, we have last or third quarter. So do you see where at these two positions, actually we have a 90-degree angle going on, okay? Excuse me. And so you'll have high tides every 12 hours, but they'll kind of be diminished. Okay, that's what we call Neap tides, and it happens at first and third quarter, test question this semester. Okay. A couple of other things then related to this idea that there's an interaction or an influence that the moon is having on our large bodies of water here on Earth. I mentioned that the bulge is a little bit in advance of, behind, advance? Yeah, I think it lags this is showing it kind of, no, okay. One of the things is that this sort of kind of pull that the moon is creating upon the large bodies of water, actually the Earth is slowing down. Okay, the Earth used to spin a lot faster, and now it's actually slowing down a little bit because of that. The other thing is that because of kind of, and it's kind of almost like a torque thing. So if this is the Earth and this is the moon, and it's kind of like a hasta la vista moon sort of thing, the distance between the Earth and the moon is increasing. Okay, and again, it has to do with kind of this gravitational special connection between our oceans and the moon. Okay, so the moon is spiraling outward. Okay, so when you go to those planetariums and they say the moon is, distance between the Earth and the moon is getting larger, they're right. Okay, the last thing I kind of want to show you, okay, is this. So back earlier in this course, in an earlier chapter, we talked about how the this is the Earth, the center here. So this is the very similar figure we looked at before. Here's the Earth, and kind of that red circle is the orbit. Oh, I should go this way. That red circle is the orbit of the moon about the Earth. And we said that we only see one side of the moon, and that's called the near side. So right here, actually, there is no rotation of that gal. So we don't see the same side of her, okay? And here we do see the same side of her. Remember, the reason we have a near side of the moon, we only see one side of the moon, is because that the rotation of the moon is exactly equal to that time, is exactly equal to the time it takes the moon to complete one orbit about the Earth. It's called synchronous rotation. And actually, it's kind of this interaction, again, between the moon and the Earth's oceans that tidally locked and created, became tidally locked and created this synchronous rotation. Okay, and actually we see this with other planets too.